Well, welcome back to our daily elementary mathematics. The essence of this class is to prepare prime 4 to 6 pupils, and also for those who will be writing common entrance into secondary schools. So now we want to consider this topic, lowest common multiples. How do we find lowest common multiples, abbreviated as LCM? So we have this example here. Find the LCM of the following numbers or terms. So we have LCM of 4 and 12. B, we have LCM of 18, 24, and 30. And C, LCM of 12x squared y and 15x cubed y squared. So how do we find this? Well, we already from the previous lectures, we know what multiples are. If you are asked to find, for example, multiples of 6, you say 6, 12, 18. Those numbers that are divisible by 6, that is the result we get when we use natural numbers. Sorry, when we use natural numbers to multiply 6 itself, the result we get are multiples of 6. So here now, for example, if they say the lowest common multiple, before we know the common one or the least that is common among the multiples of 4 and 12, we can first say multiples of 4 include 4, 8. Because if you say, sorry, if you say 4 times 1, you get 4. 4 times 2, you get 8. 4 times 3, you get 12. 4 times 4, you get 16. 4 times 5, you get 20. 4 times 6, 24, and so on. The same thing for 12. 12 times 1, 12 times 2, these are multiples of 12. So among these multiples, which one of them, check the multiples, which one is in these multiples of 4 and it's also in multiples of 12, that is common to the two of them, the least that is common to the two of them. If you check, we can see that it is this one. That is 12 here and 12 here. That means the least common multiple, or the lowest common multiple, the least among them that is common to the two is 12. That's why we say the least common multiple of between 4 and 12 is still 12. So this one way of working it, but it is not advisable that we have to list out multiples before we can find the one that is common to the numbers we want to find. Now, the reason why this is not advisable is because suppose it's a large number and you have to list and list and list. And don't forget that in mathematics, we are not only working towards accuracy of answer, we also work towards speed. You need to enhance your speed too, to be able to answer questions as fast as possible. That is why it is necessary we learn this method too. This 4 here, you express 4 in index form. We learned how to express in index form in the previous video. You break it down, 2 to the power of 2 is index form of 4. And for 12, 2 to the power of 2 times 3 to the power of 1 is the index form of 12. For those who are just watching this video, go and watch the previous one. That's where we treated, I think lecture 6, that's where we treated how to express number in index form. So when you express in index form like this, then the next thing you do is to say, here, 2 to the power of 2 is there, 2 to the power of 2 is there, so you choose one. Suppose one of them is 2 to the power of 3, while the other is 2 to the power of 2, you choose the one with higher power. So, but since both of them has 2 to the power of 2, so you choose that 2 to the power of 2. Then this one is just 3 to the power of 2, and it's not even appearing here. So just choose it like that. It will be 2 to the power of 2 times 2 to the power of 3. And 2 to the power of 2 is 2 times 2, which is this 4. 3 to the power of 1 is 3. So 4 times 3 is 12. So we still get the same answer as we got here. Now we can apply this method too to answer question number 2 above. That is B, question B here, which is 18, 24, and 36. 18, we want to find the LCM of 18. Sorry, let me quickly check. 18, 24, and 30. 18, 24, and 30. For 18, if you break it down, 2 can go 9, 3 can go 3, 3 can go 1. That means 2 appears once and 3 appears twice. So you do for 24. If you do for 24, we have 24, 2 can go 12, 2 can still go 6, 2 can still go 3, 3 can go 1. So 2 appears 3 times and 3 appears once. And similarly, we do for 30. 30, 2 in 30, 15, 3 can go in 15, 5 can go in 5 once. So that means 30 produces 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1, because each of these numbers appears once. Now, to get our LCM, that means LCM of these three numbers, 18, 24, and 30, will be what we are going to, we have 2 as base. That's among the family of 2's here. 2 to the power of 3 has the highest power, you choose it. Among the family of 3, 3 to the power of 2 has the highest power, you choose it. And it's only 1 5 that appears, so you choose it like that, since there is no other one to compare whether the power is higher than that. So that means we'll now get 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 1. And 2 to the power of 2 is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That is 8. 3 square is 3 times 3. That is 9. And 5 to the power of 1 is just 5. So you have to multiply this number out. If you say 8 times 5, you will get 72. And 72 times 5, you get 360. 360. That means the LCM of 18, 24, and 30 is 360. We quickly go to C. In C, we have 12x squared y and 15x cubed, 12x squared y and 15x cubed y squared. So we have the results here. You know what we do? So for 12x squared y, we break it as, just break that 12 there. 2 here 6, 2 here 3, 3 here 1. That is 2 to the power of 2 times 3 to the power of 1 times x squared. The letters are already expressed in their index form. So we have this. Then we, in the same manner, break 15. 3, 5, 5, 1. So 15x cubed y squared will give us 3 to the power of 1 times 5 to the power of 1 times x to the power of 3 times y squared. So if you look at what we have here, we can now go ahead and begin to check. If you want to find the LCM now say the LCM of these two numbers, or these two terms rather, will give us, check, in the family of 2, which one has the highest power? Is just these two. So we have 2 to the power of 2 times, in the family of 3, both of them, have 3 to the power of 1, 3 to the power of 1, just choose one, 3 to the power of 1. In the family of 5, it's only this one that exists, so 5 to the power of 1. And in the family of x, we have x to the power of 3, we have x to the power of 2, choose x to the power of 3. And in the family of y squared has higher power. This will now give us, we have 4 times 3 times 5 times x cubed times y squared. And this will give us, if you say 4 times 3, you get 12. And 12 times 5, you know, is 60. So that is 60. And we now have 60 x cubed y squared as the SCM of these two expressions. All right, thank you.